Hey, what's going on? Today we're going to talk about electric and plug-in hybrids. Well, actually, the title might be a bit misleading. We're going to talk about plug-in hybrids and electric vehicles. So what is a plug-in hybrid? PHEV. A plug-in hybrid electric vehicle is a vehicle that is designed to be plugged into an electrical outlet charging station to charge the onboard battery while the vehicle is off. Unlike a non-plug-in hybrid that actually generates electricity from gasoline, pure 100% gasoline, at least a gasoline hybrid vehicle does. Like a Prius, right? And then again, the plug-in difference is it has an outlet or port or means to plug it in with from grid power or outside electricity. So by charging the batteries with an exterior source, the vehicle can operate using electric power only for longer times versus the ICE hybrid and its internal combustion engine hybrid. I know this picture is a picture of a Tesla Roadster, and you're like, that's not a hybrid or plug-in hybrid. It's an electric vehicle. I get it, but I like them. So, and I'm teaching, so hey, what the heck? No, really, it actually shows a charging cable right here in this person's garage. And we'll talk more about this EVSE, electric vehicle supply equipment on the wall, and this charging cable and how that works later. So how do you identify a PHEV? Don't worry, it'll tell you. Ha, just kidding, it's a joke, right? So since PHEVs are basically the same as an HEV, a hybrid electric vehicle, there are only a few ways to identify them. They are as follows. You're going to have an extra fuel door. Now on the Prius, that's a plug-in. You're going to have a little fuel door there with that plug-in receptacle logo, and or it's going to say plug-in hybrid on the back or side of it. Okay, it'll have some type of a badging. Fords, they say Energy with a little plug-in on the E. So different manufacturers, they're proud of it. They're going to tell you. So that's one way. And again, the second way is the fuel door there. Here's the Ford Energy. See the little E's, the plug-in. Oh, how cute. So good old Ford, and you got the Leaf, of course, meaning you're saving the world. And then here is your charge port indicator light ring thing Ford uses. It's kind of a cool little light. So when you plug in the EVSE, this plug, notice I said EVSE, not charger, because typically you're not plugging in the charger, you're just plugging in the wall grid to the car. The charger's on the car. The box on the wall is called an EVSE, electric vehicle supply equipment. This is the handle, probably it's a J1772 format, which I'll show you a little bit. But what's cool about this ring is when you plug it in, this whole ring will light up if it's fully charged. Let's say it's got 20% charge. These will be off, and this first section, 25% here, will be blinking, meaning it's charging and it's between 0 and 25%. Once it reaches 26 to 50, this light goes solid, and then this section blinks. When it goes 51 to 75, this section will blink, and these two are solid, and then above 75, so 76 and above, these three will go solid, and this one blinks. The cool thing about that is you can look out your window or look in the garage and say, hey, I got a full charge, or wow, I got nothing, I'm walking today. So kind of cool novelty. Volt's got a little light on their charging ring as well. And then this is kind of a picture of the Chevy Volt plug-in hybrid battery pack. Lithium ion, it goes across the center console and the back seat right here. This little deactivation switch right there is in the center console. But other than that, the operation of a plug-in hybrid vehicle is similar to what you learned so far in class. Just basically it's got a charging port, large battery, and an onboard charging module. So not a whole lot different. All the safety, PPE, all the protocols, live, dead, live, that stuff stays the same. But you have, again, a charging port, larger battery, and an onboard charging module. So keep that in mind. Here is the back of the Prius. We got a Gen 3, looks like. Prius, plug-in hybrid. There's a couple things you'll notice that are different from what you remember in class. From the Gen 3 Prius we have in class that's not a plug-in. And of course, you remember the battery across the back. This one has bigger battery. It goes way out here where the spare tire used to be. And it has not one, but two disconnect switches. So again, a little bit different from the HEV, but you know what those switches are. You know how to deactivate it. You've done live, dead, live. There's another one. So read your service manual and pay attention. You got a bigger battery. You're gonna have to use a cherry picker of some sort. That's really the main differences. So large batteries weigh and cost more. Smaller batteries have less range. So engineers will do this balance on the car. They're trying to meet the demographic that they think the car will buy. If they think they want a long range, they'll invest in the expensive big batteries. If they don't, they want a cheaper car, they might have a smaller batteries with less range. It just depends on their demographic. When they guess right, they sell and they're successful. So kind of a compromise, right? Here's a Chevy Volt. So in comparison, the standard HEV Prius has a 1.3 kilowatt hour battery. That's what you had dealt with in class in the back of that Prius. That big giant battery in the Prius was a 1.3 kilowatt hour. This Chevy Volt basically comes with an 18.5 kilowatt hour. That's up from the 4.4 kilowatt hour in the plug-in version of the Prius. So in perspective, this Chevy Volt can go about 50 to 60 miles on EV alone. The plug-in hybrid can go about 12, maybe 12, 13 miles per that. And the standard HEV Prius just goes a couple, 2-3 miles before the ice has to kick on. Real small battery. It's really there for the most part just to make a really efficient transmission. If you remember that from the transaxle class we talked about. So charging the PHEV. After the battery has been discharged, the ice is used to keep the battery charged enough to propel the vehicle, but it does not fully recharge the battery. Okay, so again, on the hybrid non-plug-in, the ice charges the battery using gasoline and that generator, right, making electricity. So the battery is 100% charged from gasoline. That energy is made 100% from gasoline. It isn't until you go into a plug-in hybrid that exterior source grid power is propelling your vehicle. So to fully charge it, you plug into an external power source. Here's that C-Max. Actually, it's a pretty comfortable car, a lot of headroom. And basically your exterior charging sources, they come in different levels. You'll hear a lot level 1, level 2, and sometimes you hear level 3, although I think snobby kind of EV people kind of scoff at the term level 3, and they say, oh, no, level 3 exists. It's actually called DC fast charge. Whatever. Basically, it's the next level. So there's level 1, level 2, and then DC fast charge. We're going to talk a little bit more about this in a little bit. But study this, pause this video, look at this graph. This will speak a lot. It's basically giving you an idea of what's going on. So a level 1 is kind of the charging cable that the car came with. You plug it into the outlet in your house. Like think what you plug your toaster into. That's a 110, 120 volt, 15 amp breaker receptacle, right? So you're not going to get a whole lot of power out of that. Thing right here, you're getting 1.4 kilowatts at 12 amps. That's going to be equivalent because this is kind of all new, apples to oranges. You're thinking, I know gasoline, but electricity, 1.4 thousand watts. What does that even mean? Basically, you're getting 3 to 4 miles of charge every hour. Okay, so if you have a BEV, it's going to take, that's a battery electric vehicle, 17 hours to get a full charge. Plug-in hybrid, because they have smaller batteries, is 7 hours. So of course, you'd want the level 2, which is the bigger, badder, beefier one we saw earlier in that Tesla garage. That's going to be wired into 240 single phase up to 19,000 watts and up to 80 amps. 80 amps over the 12 amp, to 15 amp circuit. Now, this is where it changes based on your car. Your car either has an onboard 3.3 thousand watt charger or a 6.6 plus thousand watt charger. If it's got the beefier one, which most new plug-in hybrids and electric vehicles do, especially like new electric vehicles have this bigger one, like the new Leaf. And of course the Teslas have even more. You got right here 17 to 20 miles of range for every hour versus the 3 to 4. So again, this 3 to 4 is equivalent of filling up your gas tank with a syringe. Gonna take a while. The good news is most people only need level 1. And you're thinking, what? I would not be happy at 3 to 4 miles an hour. Well, that's because you're thinking of it like a gasoline vehicle, where you pull in, you slide your cart into the pump, you spend 5 minutes pumping, and then you take off onto your merry way. Well, electric vehicles are different. Excuse me. Electric vehicles, you get home, you plug it in, and you go to bed. So imagine like someone, if you plug your gas, or you drove your gasoline car in the garage and you went to bed and somebody filled it up with a syringe all night. Yeah, it'd take a while, but it's going to happen. And you didn't do any work. You're just in bed or cooking dinner or whatever. So that's kind of how electric vehicles work, is you plug them in, you go have dinner, you go to sleep, you wake up, you unplug it, and it's fully charged for the most part. But if you have this level 2 with a 6.6, you're getting 17 to 20 miles. That same BEV that took 17 hours is now 3.5 hours. And that plug-in hybrid that was 7 is now 1.4. This comes into factor comes into play if you're traveling or you're using the car on the edge of its limits. You're going to slowly lose miles every day if you're like, kind of like treading water. So that level 2, we'll talk more about that later. And then there's DC fast charge. Now what makes this different is on level 1, level 2, these plug into the onboard charger that then routes to the battery. The DC fast charge, level 2, or also known as level 3, I've heard both again, that goes right to the battery. Again, by the name DC fast charge, it bypasses the onboard charger and goes straight to the battery. So it has, in that instance, then it would be kind of a charger. That one would be a charger. But look how powerful this is. Typically in a 400 plus volt range, up to 90,000 watts, 200 amps over 80. Holy Toledo. 45,000 watt charger. You're getting 50 to 60 miles in a half-hour charge. Whew. Yeah, this is Tesla stuff right here. So that makes it doable to go travel. I mean, so if you got to go that same 17 hours, you spend 30 to 45 minutes charging, you go another 300 miles, 300 miles, high 200s, low 300s, and you got to wait 30, 40 minutes every time. Yeah, it's slower than gasoline, but maybe you should get out and take a break. You're driving, relax, enjoy life. So those are the charging levels that we're going to talk about. Here's some pictures, because I like pictures. You probably like pictures. So level 1, this is the one that comes in with the car usually. You plug this into the wall, you plug this into the car, and you wait and wait and wait. But this works good if you're at work, and they let you plug it in. Or you can just plug it in the garage, you go to bed, you wake up, and it's charged. So it's cheap. You don't have to install anything. It's good to go. And honestly, 90% of the people are fine with this. If you only drive 20, 30 miles a day, you're going to be fine with just this. Level 2, this is where you start getting again to that bigger EVSE, right? This is where you have to have a professional electrician come in. They have to be installed. This is 220 plus. You're going to get a lot more amperage. It's going to charge a lot faster, but that charging EVSE, electric vehicle supply equipment, this box is basically a fancy computer and relay plugged into the grid. That thing could cost you $500, and then you got to have someone install it, and that can add up. So do you need it at home? I don't know. Definitely commercial. You'll see it like in this picture in the commercial areas. You'll see it a lot for many reasons. One, it lets you charge while you're at work. A 6-hour shift. If you got lunch or whatnot, so you can get a good solid 6-7 hours of charging every day, and it usually gives you upfront parking. So people sometimes buy electric vehicles just for that. Who knows? So level 1 and level 2, their charger plugs are J1772. That's just a protocol. That's the format of what they look like. They look like this. So you have your AC lines right here in the center. Okay, your neutral and your ground and hot. And then these two right here are your communication wires, your pilot and proximity. And what these 2 pins do is they're going to tell the vehicle, 1, that you're plugged in, and then 2, at what charging rate, and is there an error? Are we fully charged? Stop charging? All that communication happens on these 2 wires right here. They're low voltage. These 3 in the triangle, these are high voltage. And if you look, these ones are out here first contact, last contact, which means these are the last contact, first break. See how they're recessed in? Which means there's no power on this pin. There's no power on these pins until these make contact last. And then when you unplug the connector, these break contact first, which kills power to these pins before they open contact. It does 2 things. Saves arcing in here and saves them from melting, and also will limit your exposure to high voltage. So good things. That's your AC plug. And then they also have the DC AC/DC. This lower end, this is your DC fast charge. And this is kind of a new protocol plug. It's actually relatively new. This is your J1772 on top, and then they added this bottom one right here, this DC fast charger, is right to the battery. So, and then you have level 3, which is your Tesla, your big dogs, 440 volts, charging stations, 200 amps, real power, right? Real power. And then you also have Nissan does this CHAdeMO, which stands for, its abbreviation, which means charge for moving, charge day move. And this comes from Nissan, and it's got expansion holes right here. But basically, these are your DC fast charges to your battery, and these are your communication ones right here. So That concludes video 1. We'll see you at video 2.